Start. Hello, everyone. I'm Zamani, and I'm the moderator of this talk. I'd like to first thank Claudia Hauff for accepting our invitation and joining us from the Netherlands. And she's kind of spending her Friday evening with us. Claudia is an associate professor in the Web Information Systems Group at the Delft University of Technology in the Netherlands. She's received her PhD in 2010 from the University of Twente. And in the past, she has worked on a variety of topics related to information retrieval and data science, including query performance prediction, which, if I'm not mistaken, was her PhD dissertation, social search, learning to search, and information retrieval for specific user groups. Together with a number of PhD students, she currently focuses on the areas of search as learning, collaborative search, and conversational search. And today, Claudia will talk about on the support of human learning during search and sense-making activities. Claudia, please.
All right. Thank you very much. Thank you for the invitation. And yeah, maybe as Hamid listed, I'm interested in many different topics. So I'm not somebody who sticks for like 10, 15 years to the same topic. One thing I want to point out is that you said query performance prediction, which was really out of fashion for a while, but now won the best paper award at CIIR 2021. I haven't read the paper yet, but it seems to be a topic that is getting hot again. The second topic I do is conversational search a lot, but then I saw that there's already a talk in your history by Christian Balog. So I thought I'll do my third main topic, which is search as learning. And what I want to do in this talk, I basically want to give you an overview of kind of what has been happening in search as learning, what are the challenges, how are we approaching this problem? And this means not only including papers of my own team, but also other people's work. Now, of course, this cannot be done by one person, so I have quite a large number of collaborators. These are all PhD students, apart from David Maxwell, who's a postdoc. So whenever I present papers from my team, it's with at least one of these people: Arthur, Guanliang, Dan, Felipe, Nirma, Manuel, and you. All right, so what do I want to cover in this talk? Well, first of all, I want to introduce the topic of search as learning. There might be some of you that have never heard of it. If you go to CIIR, the Interactive IR conference, it's a topic that comes up again and again these days. So if you belong to the CIIR community, you will know about it. If you go to CIIR, it's quite hard to find papers on this topic. And then I want to go into like kind of different directions of the kind of research that is happening within SAL, or search as learning. One is how to measure learning. So if you think about search, well, if I just have the interactions on my search interface, how does it help me to determine whether learning took place? Then I will look at different ways how we can influence how people search and learn while searching through user interface choices. And then I will also take like a 1-2 slide tour to the retrieval backend. So the kind of work that's happening to change retrieval functions to encourage learning. So why are we actually looking at this? Well, if you think about search, then typically, especially web search engines, they are optimized for relevance, right? They're optimized for clicks on ads. They're optimized for quick answers. They're not optimized to give you the best possible learning outcome. At the same time, we know that for many people today, when they have to learn something, they head to the web. And so in 2012, there was a Swell report, and where this topic of search as learning kind of was picked up as maybe as an influential future research direction. And then in 2014, there was this nice assist paper where So-Young Wu says, well, this is a new research agenda, so search as learning. It focuses on the impact, influence, and consequences of using search systems as learning technologies, right? So this is really the main point. We're still squarely focused on search, but now the purpose is not to find documents as quickly as possible. The purpose is to learn as much as possible as a human. And so this is really strongly influenced by this 2006 paper by Marcianini, where he said, well, in exploratory research, we have two parts. One side is to learn, and the other side is to investigate. And so what it means to learn, of course, means different things to different people. And this will also come out in this talk that although there are a lot of papers nowadays on searches learning, if you dig into them, oftentimes you find quite a lot of differences of, well, what do people actually look at? What do they consider learning to be? When I talk about the papers in my team, you will see that they're often quite similar in the sense that the experimental setup is always very similar because it's actually quite hard to run these kind of experiments. All right, so one more time, here's the kind of the distinction that we make when we talk about searches learning versus something optimized for relevance. So at the top, you see a simple search task that web search engines can do brilliantly, right? They just give you a direct answer, that's the weather. And then at the bottom, you see a search task that search engines nowadays typically fail, right? So if you have a question like, how have political decisions in the US and the Netherlands shaped solar panel pricing in the last 5 years? Well, you wouldn't even start putting this into a search engine, right? Because you already know, well, this will fail. So you automatically already start to decomposing this query or this statement into separate queries. And if you have to actually learn about this topic, not just find documents, you probably also know, well, what kind of other software tools and maybe notepads and so on you have to look into and to start setting up to actually get to your answer, right? So complex search is this exploratory, open-ended, multifaceted search task with the goal to learn something for us. And as I said, search and sensemaking plays a big role. And so in grant proposals, this is usually a kind of an image that I put in like every grant proposal so far that was successful. I'm not sure if it's this image or if it's just like I spend more time writing those. But basically, the main argument here is to say, well, we know people use the web to learn, but we know comparably little of how to improve that, right? How to improve the search experience for them during that learning phase. And that is a scientific challenge, right? So since we know so little how to support users in these complex learning-oriented search tasks, well, we also can't help them, right? So the first step is to learn more about how do they search when they have learning-oriented needs. And once we know this, the second step then is to actually build interface, widgets or change the retrieval function and so on. And so on the slide here, I also put collaborative search and sensemaking. And that's because, well, we've also started to look at if collaborative search can help in this endeavor. As you will see in one of my slides, it actually does not help at all. So if you use collaborative search, people actually tend to learn less than if you just give them the standard search experience. And then the sense-making part that you see here, well, this is something that you often see in information science research. This is not something we've really tackled a lot, but it's definitely important, right? So search is one thing, but of course, you have to give users the ability also to make sense of what they see. And we're starting to look into this and how to put this kind of sense-making tools in a good way on the search interface. So what is my ultimate vision? This is another image I put in one or two grant proposals. So basically the ultimate vision is to say, well, we have a search system that can do conversational search if need be, that you give your very complex learning-oriented search need. And then the system automatically decomposes your need into different subtasks, and it can automatically track to what extent what you've read, what you've viewed, and what you've clicked is kind of completing these subtasks. So that's what these little indicators are, right? So in this case, you know that, well, you should focus on subtask 3 because you know the least about this. My vision interface also has something like a timer. So if I know I can only spend 30 minutes to learn something, I should receive different documents and different viewing experiences than if I know I have 3 hours to learn something. It also allows me to set like, how much do I want to learn? So do I just want to pass a test and get like immediate, like, initial knowledge, or do I actually want to become an expert, right? Of course, that should also change the kind of documents I see. In order to learn, we know that it's important that you're able to test yourself. So if you think about how you learn, then it often helps, once you've read something, that you get a few questions on what you've read, right? And even if you don't know the answers to these questions or you don't see them, it helps you to reflect on, well, how much have you understood, actually? So having these fully automatically generated infinite, quiz engines would be great too. And then lastly, of course, we want to track progress over time. And so this is kind of my perfect search as learning search system, that basically would help you as much as possible to learn something. Now, where are we with this vision? Not very far, I have to say. We tried, as you will see later, we tried a bit of scaffolding and highlighting and note-taking. We're working on this automatic question generation part. But I mean, there are so many gaps that remains a vision for years to come. All right, so here's another thing. Why is it such a problem? So if we go back to how current search engines work, well, then the kind of negative view you can take on this is that search engines take over users' thinking nowadays, right? So you put in a few keywords, and sometimes you even get the direct answer, right? So there's actually not a lot of thinking on the user's part, which is bad for human learning, because usually thinking means you reflect, reflection means you learn more. The search engines also structure the user's activities. So there's a certain way in which search engines enforce communication, right? With the 10 blue links, with these little dialogues they sometimes have. But it's a particular kind of type of communication that's enforced. Again, not great for learning. And of course, the search engines, they are not optimized for anything that has to do with human learning, but they're optimized ideally to, you to click as many ads as possible. And we also know from information science research that actually the younger people, so they call this, first of all, the millennial generation, which isn't young anymore, it's like 1 year below my generation, but also the Google generation, which is a bit younger, that they're essentially less able to search well. So there are these two influential papers. One of them says that the millennial generation proceeds erratically through their search process, does not validate sources or the information gathered. So they're less able to search well, meaning they're also less able to learn well when searching. Similarly, the Google generation appears to behave differently from older generation. It's less confident about the search power, so the searchability, and the search statements were much more the product of cut and paste. So from the given information need, they basically just copy and paste, cut and paste words. So together, this means that, well, we're not getting better at search, but we are basically leaving more of the thinking to the search engine, which again is not great for learning. All right, so this is where search as learning comes in. Now, why is search as learning difficult? I think there are many answers to this. My answer is that it's difficult because it's interdisciplinary. So unfortunately, as an information retrieval, as a computer science person, I cannot just write papers about search as learning, ignoring education and psychology literature, right? You need to include this literature because it actually tells you what promising research directions are. I mean, education has been busy, forever with how do you get people to learn. And there's a vast amount of knowledge that is, at least when I look at this initially, really hard to grasp. The way they write papers, the way they convey ideas is just so different from computer science. And then of course you have the psychology side that is also very actively looking into kind of, how to make people behave better or learn better. So there's, a lot of things outside of our expertise we have to look at, and we have to kind of try to integrate into our line of thinking, which makes search as learning so hard. Which also makes it difficult from a point of view of kind of having a unified field. So there was just recently a paper I read from the Web Conference 2020, where somebody did search as learning, and they called it something which I'd never heard of in my life. But I've written paper about the same concept, but I just call it something differently because I'm reading the education literature, not the psychology literature, it turns out. So this is really what to me makes it so tough, that you actually need to draw from a lot of different expertise, which is not readily available as computer science. All right, so these were kind of my global statements. Let's go into a bit more details. So what else makes it difficult? Well, data, task, and users. So one problem we have in search as learning is that data is scarce. We don't have MS Marker or anything like that, where we have nice click data and nice queries, and we can run lots of cool deep learning models. So the insights we have are usually survey or interview based, which is not great. Right? We need user studies, ideally those that are longitudinal. So there's one by Mark Dron that's already older quite now, but they basically said, well, here's a master course where people actually needed to look at a certain collection of documents. The teacher allowed them to put those documents into their search engine that had a particular setup. And so they could kind of force these 25 students to use their search system for 4 weeks, which is great. But of course, that's not, that's not scalable. And most of the times you don't find these courses where you can just grab 25 students to work for you, as participants. And it's also very tedious in a way. Now, we also have a very limited grasp on the task. So what happens in practice is that we typically look at the data we have available, and then we see what we can do with it. So there's this very nice paper by Carsten Eickhoff, Lessons from the Journey, a query log analysis of within session learning, where they look at Bing logs, and they basically say, well, let's look at search sessions, and let's figure out what the last click is about. So if the last click goes to a Wikipedia page, you assume that, well, this search session is about learning some declarative knowledge. If the last click goes to ehow.com, which is a popular portal to learn how to do something, then this search session is about procedural knowledge, right? Which of course means that once you have these definitions, you have a large scale query log that you can say, well, now I have sessions, for learning. But of course, it's very noisy, and it only allows you to basically look at procedural versus declarative knowledge, right? So ideally, we have a much more principled design, but that's really tough to set up. Now, the last point I want to make here, why is it hard? And that's a non-compliance issue. So let me give you a few non-compliance examples. So in this pre-talk chat with Hamid, I said that I got a couple of 3 PhD students from our MOOC Institute, sponsored basically. So at TU Delft, we have one of the largest MOOC programs in Europe. We are fully dedicated to edX. And of course, they wanted to do research with the data, right? It's a lot of log data that you get from the MOOC learners. Any click they make on the edX platform, you get. And so we said, oh, great, we can run longitudinal experiments. And then we had these issues of engagement and retention. So engagement means, or the lack of engagement means that few learners engage deeply, and the lack of retention means that the vast majority of learners actually don't complete the course. So the worst MOOC we have in Delft is one where less than 1% of people that started actually finish it. And that's a mathematics MOOC. All right, so the issues we had. So we built one tool called IntelliEye, which basically is a webcam-based tool. It kind of follows you around. And if it thinks you don't pay attention to the MOOC anymore, it gives you an alert. It's fully privacy compliant, so no data leaves your machine. So there's no spy that kind of looks at you and says, learn. So we deployed this to 820 learners, and then 70% said from the start, nope, I don't even want to try it. And the other ones, well, they tried it once or twice, and then they were like, oh, that's no, we don't need this. Now here you could argue, well, maybe it's a bit too intrusive, right? It's like a webcam-based system that kind of observes you. So we tried something else. This is called self-regulated learning. So in the education literature, there's a whole bunch of literature that says, well, if you make a plan about what you want to learn, you do much better than if you don't make a plan. Fair enough, right? So we said, well, we add a little widget to edX where we basically tell people this. Hey, here's the literature that says you should make a plan. And then we just ask them to make a plan. And the plan is really simple. I plan to watch that many videos. I plan to answer that many quiz questions, and I plan to spend this many hours in this course this week. Now, we had the course of about 2,000 people, and 87% never submitted a single plan. Although it's only 3 little numbers that we want, that's it. Worst case was then our search system. So we had the Search X, the search system we have developed with like a domain-specific corpus, which was specific for this particular MOOC. So this MOOC had more than 9,000 people. And then, you know, most people just said, nope, I use Google. I don't even want to use anything else. So this is the problem that basically we have as well. If you go out into the real world, especially if you have access to MOOCs, you know, it sounds so enticing, but in the end, it's usually a hugely demotivating experience. All right, so the last frontier I want to make is, so why is it possibly demotivating? Well, if you are looking at MOOC learners, and so this is what we did with one of the PhD students here, you know, one of the questions you also should ask yourself is, well, what is their motivation, right? And that's actually for all learners, not just MOOC learners. So are they extrinsically motivated? So are they motivated, you know, by getting the degree, by monetary gains, or are they intrinsically motivated? Like they want to learn for learning's sake. And this you can actually test very nicely in MOOCs. And here we did this. So in this example, we looked at the MOOC that had 8 weeks of course materials, and you could pass at the earliest in week 5. And then we looked at basically, well, what happens when you pass, right? If you're intrinsically motivated, you shouldn't care. You should continue learning. You should continue answering these quiz questions that are typically in MOOCs. If you're extrinsically motivated, you'll probably say, okay, thank you very much. I got the certificate, I'm out. And so in this MOOC, this is functional programming with Haskell, one of the less useful languages in functional programming, I would say, at least in industry.
What? I'm sorry. Are you killing me? Not seriously.
In industry.
Okay, I will shut up.
Okay, so we have a Scala MOOC, which runs much better. So this was Haskell. And so we looked at, well, what happens when people pass, right? And so the vast majority, so these numbers are small, but the vast majority, so we clustered them into 2 groups of people. The vast majority continued studying, right? They answered quizzes until week 8. And then you had like the minority that dropped off, which is like, great. Lots of intrinsically motivated people that don't stop learning. Now, a very different plot you see when you look at data analysis with Excel. So this was another MOOC, super popular, 60,000 people. But when you look at this plot, they immediately stopped. As soon as they hit week 5, they got a pass, they stopped. So there was a lot of extrinsic motivation. People did it because, you know, their company wanted them to have a certificate or something. So it really differs, you know, based on the motivation as well. All right, so I should not have said anything about Haskell. All right, so here's the kind of the last introduction slides. Here's a couple of things I want to mention, a couple of phrases that are important in searches learning. One of the things that is important is Bloom's taxonomy, which education researchers sometimes really dislike because it's very popular with people outside of education, because it's a very enticing way of organizing the difficulty of learning. So it basically says we have different cognitive levels. The easiest one is to remember things. So, you know, I tell you something, you remember it. Okay, it's very easy. You have to understand it, that's already harder. You have to apply the knowledge, even harder, analyze, evaluate, and create the hardest level. And so if you do courses yourself, typically what the education team is asking you is to, you know, when you evaluate learning, to have questions of different levels of difficulty, right? And so the same also applies to searches learning, right? You can say, well, how do I measure learning? Do I measure it on this lowest level, or do I measure it on one of the, you know, higher cognitive levels? Now, education researchers are, I think, not too happy. When I talk to them, they typically say, well, you know, you should better use something that's not as agnostic to the domain as Bloom's taxonomy. But in IR, I found, and I also like it, it sounds good. You know, it's easy to understand and it looks great. That this is a very popular way of organizing cognitive levels. Now, then we also talk about a lot about self-regulated learning. And so this has to do with this planning. So it's the ability to plan, monitor, and actively control the learning process. And self-regulated learning can be supported. So I can ask people to make a plan. I can, for instance, use these question generators to generate kind of infinitely many quiz questions, because it helps you to monitor, how well have I understood this concept. Then we have what's called retrieval practice. So it's nothing to do with CIIR. It means that we aim to reinforce prior knowledge by repeatedly recalling relevant information. So in the MOOC, we one time did it that we randomly popped up questions that you already answered correctly in the past. And then many people got really annoyed. They learned more, they got better grades, but they were really annoyed about this. Robust learning means that we want to achieve deep conceptual understanding. So we don't just want to remember things, but we actually want to apply, analyze, evaluate. And then lastly, we also read and spend a lot of time on scaffolding, which is techniques that support learning. So, in the physical world, a scaffold supports builders, and in the learning world, it means I give you a structure that you could hold on to learn something, right? And so I have a couple of slides of, to what extent we have implemented this already and to what extent this has been shown to work or not. All right, before I can go to this, I want to talk about a little bit about search as human learning process, because as I said, there are different interpretations of what search is. Now, let me first go to the search engine perspective. So from the search engine perspective, the vast majority of searches is not complex. It's not learning oriented. So there's one older paper by Deborah Donato and their colleagues where they try to figure out what percentage of web search queries are actually complex. And well, they called them research missions, and they found about 10%, which is not a lot. Instead, many of the searches we have today, we can answer with information cards, proactive information delivery. So, you might just, what is flour made of, as you see in the second example here on Google, and then you already get, a bit more information like imagery and so on. And we also know from the search engine perspective that, search engines have to deliver results very fast. Otherwise, people leave. So this is the restriction they have. Now, if you think about search as learning, then there was a time before we had these search engines where we did what's called reference interviews. I'm actually too young for that. I never did one, but I have a lot of older colleagues who actually talk about this. So they actually did go to the library and they did talk to a librarian to have like a dialogue about, what is right information. And the librarian tried to, make sure that, the right kind of unambiguous information need is surfaced. Now, the problem with these interactive dialogues was in the past that some studies say only about half of the referrals of these librarians, to this particular book or this particular paper were actually correct. But this is something that is often brought up as kind of an intuition or as an idea, how can we get back this interactive dialogue that we used to have like in real life with the search engine, which combines actually search as learning and conversational search in a very nice way. Now, then there's also this idea of slow search, right? So this is a paper by Jamie Teven that argues, well, we know that, often search engines actually should not be pressed for time. So there are many searches where you would be willing to wait a long time if the search system would be able to give you a good answer. But of course, we don't know this, and search engines don't allow us to say, I'm willing to wait 10 minutes until you fired up all the deep learning models to give me the best possible answer. But in this paper, they basically argue, well, maybe we should do this because most searches are actually not that urgent. And they did a small user study where they actually found that, they interviewed people and they said, well, they would wait 10 minutes. I have no idea how I would answer that question. Somebody would ask me, but 10 minutes is a round number. So users are willing to wait a long time, relatively, if the results are, more to what they expect. So there is a case to be made that also web search engines, they could use much more complex models, maybe optimized for something else than, selling ads or relevance, and it will keep users happy. All right, last thing here to mention is learning to search. So search as learning has kind of two forms. Most of the time, it's really about you want to learn something, and then how can the search system help you? But there's also this other line of research, which is about basically improving your information literacy, right? So how can we make you a better searcher? And so there's this very popular paper by Bateman, which I really like, where they basically said, well, let's create a dashboard that helps you reflect on what you're doing wrong, right? And in this case, what you're doing wrong is, well, how does your search behavior or performance compare to that of experts? So they did this inside of Microsoft. So there are lots of highly educated people, lots of people you can consider search experts. They looked at, you know, how many clicks they do per query, how many search terms they use, how many, how diverse they are in a session, and so on. And they built this into a dashboard. And then they asked users to use, like participants, to use it for like 4 weeks, I think. And they found that actually the dashboard helped people to calibrate their search behavior. So people did look at the dashboard to see, you know, what am I not doing great? And then they drifted towards this expert search behavior. So this self-reflection of how do I compare versus an expert is very helpful. Now, another work kind of in this line I did with some colleagues a few years back is to actually train people to use a search engine they're not used to. So one of the problems we have, of course, in academia is that if you try to do your own interactive IR experiment and your search system isn't, you know, Google, Bing, Baidu-like, your users are kind of, they're already frustrated, right? Because they expect something else. And so the question here was, well, how can we train users quickly so that they're becoming good searchers in our specific search system? And so the idea here was to test is, well, what if I give them, you know, 1, 2, 3 training queries or training topics, you know, ask them to write down queries, they get search results, but then I also tell them, well, these would be better queries for this information need. And by the way, this is how well you did with your current query. So how many relevant documents you've surfaced. And, you know, I think this was something like mean average precision, but slightly different so that it made sense to the users. And so we compared, well, what happens if I give you the training topics versus I don't give them to you? And if I give you the training topics and suggestions that look odd but are still good versus suggestions that are good and also look good. So look familiar, look nice to users. And we actually did find that this, even training on 2 topics has a huge effect. And you nearly, I think it was, you got a 40% higher retrieval effectiveness. So people very quickly learn to use a very different search system. So which gives us hope for interactive IR experiments that, you know, with 2 or 3 training topics where we basically explicitly tell participants, here's how you would get better results. They're able to extrapolate from what we give them to be able to then also write better queries. So, you know, if you look at these suggestions, one thing you kind of see already is that you should write longer queries, right? So we don't explicitly told them write longer queries, but we just gave them these suggestions, and the participants were able to, you know, extrapolate and say, okay, this is how it works. All right, so in this kind of first part, well, what are the open questions? Well, as I said, this reference interview is really an open question. So how can we operationalize the reference interview? There's a ton of literature on the reference interview. I've just scratched the surface, but there are many great ideas in this really old literature that could apply to conversational search as learning. Another thing is we have to learn much more about learners' intent. So, you know, not every query is about learning something. So once we know their intent, maybe also how much they learn and so on, we can help them better. And for learning, I think it's also important that we need to somehow be able to follow them outside of their search context. So they might have a couple of search sessions on a topic, and then they go away, do something else, maybe read a book, talk to a librarian, you know, follow a class or something, and then they come back. And of course, their knowledge state has changed. But for the search system, you know, it's impossible to realize that. So they just do the next session. And so the search system basically misses out on this information outside of the search system. So how can we kind of, you know, figure out how to add this knowledge to the search system? The idea we had with the MOOCs was, well, we could integrate the search system in the MOOC, and then we have this knowledge, at least about the learning materials and so on. But of course, people were really reluctant to go away from their web search engine, as you saw in my example. All right, how do we measure learning during search sessions? This is a very hot topic, also because in practice, we often revert to the same thing, which is not great, but it's very scalable. So one way to measure it is through quiz-based knowledge gain measurements. We give you a pre-test. Often this means here are 10 terms. Please define these 10 terms. You do something, you do a search session, maybe 2 or 3, and then we ask you again, please define these 10 terms. Right? So this is a vocabulary learning task and allows us to measure learning. Right? Now, the problem is that a vocabulary learning task is very low in this Bloom's taxonomy. Right? It's about remembering and maybe understanding, but that's it. The nice thing though is that it's very easy to set up, right? Especially in a lab study. So that's why it's often used in practice. We also use it in a lot of our work. It's definitely not great. It's something reviewers remark from time to time. And I also totally agree. It's not a great way to measure learning, but it's a very clear-cut way, and a very easy way. Now, what else can you do? So the manual assessment of summaries is something that's sometimes done. So there's this paper by Wilson and Wilson, where they basically define different ways of measuring learning in summaries. So they come up with different metrics. And we do use these metrics in practice. So the number of facts in an essay, right? Though it's sometimes quite hard. So when is one sentence a fact, right? Or if you have a long sentence, how many facts is that? Then you have true versus, partially true statements. What is a statement? When is it true, partially true? It's not easy to do. There's also one work, I think this is by Nick Belkin and his student, where they look at mind maps, right? So here are 10 concepts, please draw a mind map. You do the search session, hopefully you learn something, draw a new mind map. But then the question becomes, well, if I have 2 mind maps, what metric can I use to come up with a number that tells me in the end, this is how much you've learned. So mind maps and summaries are definitely more detailed, but they're also harder to juggle in terms of, in the end, I want one number that tells me how much I've learned. And then there's quite a lot of work on proxy measures of learning. So we know that these pre-post-test approaches, they're lab-based, they don't work as well. And of course, ideally, I want to have my web search users, I want to know how much they learned by just looking at click data or gaze data or documents viewed and so on. And so there's a lot of work on, can I use gaze? Can I use reading difficulty? Can I use query characteristics? So the length of the query, the words in the query, the change in terminology over time. All of these things have been investigated and are still being investigated. So far, I've not seen one perfect measure, but they all do reasonably well. That's what I can say. Right, another question is when to measure learning. So typically when we have search sessions of 20 to 30 minutes, well, I would like to know, when did you learn something, right? Is it, in minute 29? Did you learn almost everything in the first 10 minutes? And so this is very difficult to track down. So I did this with one of my PhD students, and we basically got crowd workers and we asked them every 5 minutes, what did you learn? What did you learn? What did you learn? Super annoying, and of course also very noisy in a way, because you ask them all the time, what did you learn? But how else do we go about it, right? So ideally we can realize very quickly based on click data, mouse hovers, maybe gaze data, what was learned, what was not learned, so that we can run an intervention. But we don't know yet how to do this. And then Kevin Collins Thompson has one student, Rohail Syed, who does a lot of work in this area as well. And among them, he actually also looked at, well, what is the knowledge retention over time? So they did an experiment, which I didn't think would work, where they ran a crowdsourcing study. And then I think a month later, they just asked the crowd workers, do you want to come back and answer questions again? And surprisingly, many people actually said yes. So they could measure long-term knowledge retention with crowd workers. All right, so what are the problems in this measuring area? One problem is that we actually want to measure learning in a downstream task, right? I actually don't care about, how many words can you define. I'm much more interested in other, much more intricate learning tasks, right? When you learn about a JavaScript, can you actually implement something, right? But that's much harder to measure. And also that will come much later, not right after the search session. In learning, we also know that failure is important, right? But the search system doesn't want failure, right? It wants you to learn. It wants you to find relevant documents. Failure is not an option. So how can we include this failure that is so important for learning? And then, of course, ideally, we want to measure robust learning and transfer learning. So, you learned X, but can you apply it to Y? We have no way of doing that right now. All right. Third part is then going towards user interface choices. So as I said, we want to build design interventions so that we can test, well, does this change how people learn and also how people behave in this learning or oriented search setting? What do search engines do? Well, search engines actually offer quite a few things on the interface, right? We have related searches, query suggestions, instructions, and some sort of search dialogue, right? So I think this is an example from Google, where depending on which of these questions you click, the questions subsequently change a little bit, right? So it's some sort of dialogue that you have, but it's not a natural language. It's like click-based and very prescribed. So this is what search engines offer. Now, in academia and research, the first thing we actually have to do before we can talk about user interface widgets is we have to design our own search system. And so here's one. We designed SearchX, which we still use and extend and try to improve all the time, because we saw that, well, whatever was out there was very much geared towards retrieval functions, the backend, but it wasn't easy to build nice user interface variants, especially if you're also interested in collaborative search, and especially if you're also interested in having modern web technology. So we built SearchX, which is for single user search and collaborative search. And it also contains things like a widget for like a notepad that's integrated into the search interface. Might seem random now, we'll come back later in the slide. And also, for instance, a highlighter. So once you open a document in the document viewer, we have our own because we want to track, of course, what people read. We don't want everyone to click the snippet and go off to the web, because we want to keep the user in the search system to log them. You can also highlight stuff. These are just like two examples of widgets you can build. We also have a chat, and you can star things and comment things and all kinds of things that you can think of on the search interface we have included here. Second toolkit we built for this purpose just got the best demo award at CIIR, and this is Log UI. So this is David Maxwell's work. So one problem we saw a lot is that, okay, I can build the user interface and I can run experiments, but logging is actually a huge issue because the logs are super noisy. If you think about you have crowd workers, so you can't say, here's one machine, come to my lab, it's nicely calibrated, same viewport and everything. Everybody has a different machine. And so oftentimes actually the log data is noisy and incorrectly analyzed because, yeah, you have to take into account, size of the interface elements and all kinds of different browsers and so on. And so Log UI takes this pain away from you. It's basically a logger for any type of modern web application, React or otherwise. And we're currently extending it to not just have scripts to analyze logs on the fly for interactive IR experiments, but to also do things like streaming, the UI during the experiment to the server, so that in the end we don't have to say, well, why is there like a mouse hover on pixel 300 times 300? But instead we can just look at, well, let me look at how the interface looked to the user at that point in time. All right, so this is what we've done in the lab. Now, how do we use these things? So let me get to these studies. One thing we looked at is, what is the benefit, or is there a benefit to search when I have high quality instructor designed learning artifacts? What does this mean? It basically means when I have a MOOC video about a certain topic, is search competitive as an alternative way of learning? Why would I be interested in this? Well, because for many topics, I don't have this high quality MOOC video that was created, right? And so in this study, what we did is we compared 5 conditions. So the search condition, you search for 20 minutes for topic X. You have this MOOC video, high quality, nicely produced about topic X. We have video and search. First you watch the video, and then we ask you to search a little bit, anything you want related to the video. And we had 2 conditions, video plus search. One was a bit longer, so you had to search for 20 minutes. And we also had this collaborative search condition. So 2 people searching together, trying to learn together. Now, what we found is that, maybe not surprising, video plus search is the most effective. So on the right-hand side here, you see kind of the main outcome. So this was this vocabulary state change that I talked about. We had a pre-test and a post-test, and we looked at how much you've learned in between. And these numbers here mean, 1 means you learned nothing about this particular term, 4 means you know what it means. And so most important to us are these transitions here, these 2 colors. You know, the higher the better. And so the video plus 20-minute search gave us the best result. The worst result was the collaborative search condition. At the same time, though, these people were the most happiest with the experiment. So afterwards, we also asked, how satisfied are you with your learning? The collaborative searchers were by far the happiest. They really loved it, but they actually learned the least. But the conclusion here was search is actually, you know, quite competitive with a high quality video. So that was one outcome. Now here's another paper by CIIR where they looked at retrieval practice. So this is actually from the web conference last year. And they did question generation, something I wanted to do as well, and we're still doing it, but they wrote the first paper about it. So they basically said, well, you know, if I know what you read and I ask you a question about it, do you learn more, right? Because we reflect. And so they used the SQuAD data set, which is like this machine reading comprehension data set where you have a Wikipedia page, nicely formulated questions about each paragraph. And then they used that as a source. They told people, please go read this Wikipedia page. And then from time to time, they got a question. And so they found that people that had no prior knowledge about the topic they read about, they actually learned a lot when they got automatically generated questions. So the red line here means automatically generated question, whereas the violet line means no question. You just read the Wikipedia page and then you did the pre-test, post-test. And they also had this delay here where I think 2 weeks later, they asked the people again, please define these terms. Now, this was for the low knowledge learners, so novices. But then if they looked at these high knowledge learners, so experts, they actually found that, you know, asking them questions in the middle doesn't really help. So there's not a difference between, you know, any type of questions and not having any type of questions. But this retrieval practice idea, I really liked, and I have 2 students trying to kind of get better results on this. Okay, so one problem with this retrieval practice question generation is actually that you need data sets for your retrieval model, for your deep learning models, right? So we can't just use BERT because BERT does not produce great questions for learning. And so with Guan Liang, one of my PhD students, we actually set out to create a data set for educational question generation. And so the first thing you need to do is, well, you need to find data sources. So we looked at TED and Khan Academy. We did the large scale crawl. And we crawled videos, transcripts, and questions that users had about the videos. Because if I want to train a question generator, I need video transcript or text transcript plus generated questions. And we also did a little analysis of this Bloom's taxonomy I talked about. And you see here that in the SQuAD data set that's used for machine reading comprehension a lot, you know, all the questions are remembering questions, which makes sense because the people that, you know, created these questions. So here's a paragraph from Wikipedia. Please, you know, write a question. They were tasked with writing a question you can answer by reading the paragraph. So that makes sense. RAISE is another popular data set about English learning that is also mostly remembering questions. And then these are kind of the 2 columns we created. And you see here that in our data set, you actually have questions that have a higher cognitive level. Now, so we have the data set, but we're actually still busy creating a good question generator from it. Like many question generators, we suffer from basically generating non-informative questions. So this is an active area of research. All right, so the note-taking part I had talked about earlier. So I said there's a reason why I showed you the note-taking and the highlighting. We also run a study on that, which was just published at CIIR. We basically wanted to know, does the presence of active reading tools like note-taking and highlighting affect the search behavior or learn gain of users in these learning-oriented search tasks? Now, what we found is that it does not affect learning gain. So there was no learning gain. Again, we used the vocabulary task, which, I said, it's not great, but it's easy to set up. But we're looking at better things. And we had 4 conditions. So we had the control condition, standard search interface, highlighting condition, search interface, you can highlight, note-taking condition, search interface, you can take notes, and the combination of the two. And we wanted to know, what of these gives us the best results. Now, we didn't find any difference in learning gain, but what we did find is that the people in the highlighters condition spent more time reading, less time exploring, kind of makes sense. In the note-taking condition, people spent less time on the documents, but they actually wrote more down. The people in the highlighting plus note-taking condition did the worst. They had a bit of a cognitive overload. In terms of the essay writing that we also analyzed with the Wilson and Wilson metrics for sense-making, we found that highlighters cover more subtopics in the essays, whereas note takers, they write on more facts because they have taken the notes, so they are more aware of what they should copy from their notes. Once again, participants that got both of these user interface affordances did the worst. So not a great idea to overload the user in this way. All right, another thing we did also at CIIR by Arthur Camara with the Best Student Paper Award was to look at scaffolding. Now, what is scaffolding? I said,
Claudia, sorry, I hate to interrupt. We only have 4 more minutes, including the Q&A. So I just wanted to give you a heads up.
All right, I can finish this one and then I can go to the conclusions.
Okay, thank you.
All right, so scaffolding is basically this part here to make it quick. So you have an information need, learner oriented, and we tell you, these are the type of subtopics that are important. And we can also tell you how much you've already learned about these subtopics. This is the yellow part. So let me skip over the subtopics. We had these 4 conditions. So no help, no scaffolding, scaffolding by automatic query expansion, and either giving you the curated structure that you just saw without any indication of how much you've already looked at in these subtopics, and then this feedback where we actually tell you, how much you've already looked at. Last slide then is this one. So what were the results? Basically, actually the feedback that we hoped to be the best was the worst. So participants learned the least amount, and they actually spent a lot of time just clicking on documents, probably to get this yellow bar up. So we saw kind of a gamification effect, which was very annoying. What we did see is that in these, in the conditions where we gave visual feedback, so curated and feedback, that the participants were much more active. So they were much more active in their searching because they knew, they had something to hold on to. In terms of learning outcome, again, we had this vocabulary learning task. Unfortunately, we saw a trend, but not significant. So we cannot claim that, showing them the scaffold actually helps their learning. All right, so let me skip over the rest then. Just to summarize, so Searchers Learning focuses on the consequences of using search systems as learning technologies. As you saw, it has many different facets and many open issues. And there's quite a lot of tension between what the user wants and what Searchers Learning thinks is good for the user. All right, thank you very much.
Thank you. Thanks again for the interesting talk. And sorry for the interrupt. So it's a fascinating topic. Actually, given this kind of COVID time, it's kind of becomes really necessary to have these kind of systems as these students don't have the opportunity to interact with the instructors and other peers and things like that. Okay, so it's a Q&A time. There is one question in the chat by Laura Ditz, and then she said, sorry, I have to leave. I can ask Claudia later. So I will kind of skip that question. Is there any other questions? Okay, I will abuse my power to ask a question from you. So it's an interesting topic, and I am kind of interested in designing retrieval models for the purpose of these surface learnings. So I wanted to learn about your opinion. What do you think a retrieval model should look like when the task is, or the goal is surface learning?
Yes, so there's one slide that I skipped because time was over, but then I can go back to it. So there's only one work I'm aware of, and this is also by Kevin Collins Thompson, where they basically said, well, we need to take knowledge tracing, which comes from the educational literature. So you need to build a student model, right? How does knowledge propagate over time? And this is what they do in this paper. They also have a whole framework. I'm not convinced that this is a great framework because it looked really specific for that task. But I do think you already can get a long way with looking at things like diversity, novelty, reading difficulty. So I see people saying, well, reading difficulty, for instance, is not great. We need better retrieval models. But actually, reading difficulty already tells you something, is this content for novices or experts? So it could already go some way. And I'm more of the opinion we should try to look at what is already there, which is reading difficulty, personalization, diversity. And then we can say, well, we really need new retrieval models. To my knowledge, this is the only one that is there. And I have not seen any follow-up work on this. I'm also not so sure that this is really needed. But I think that the one thing that's really missing is data, right? We don't have MS Markov for search learning. How do we even get that is an open question. Once we have the data, I think everything will become much easier.
Okay, yeah, that makes sense. So we have another question in the chat. Aya is asking, I want to ask about individual differences. People have different IQ levels. I'm not sure how their IQ affect their learning. So when design an experiment to evaluate or measure how well they learn, take into consideration the individual differences.
Yeah, that's a great point. So right now it is not done. Usually we distinguish between novices and experts. So we ask questions before, and if you know nothing, we say you're a novice, otherwise you're an expert. If you know 5 out of 10 questions you get correct, you're an expert. But I think this is more to do with that, you can't ask people what's your IQ, right? There's some work, I think by Life as a Party, where they look at how, I don't know, there's this psychological concept he's very interested in recently. What is it, perceptual speed or something? So there are other concepts as well. You can kind of run questionnaires to see how good people are in this direction. But I've not seen anything IQ related. I mean, usually you would, run hopefully a study that has many participants. So these kind of uncontrolled variables are, averaged out. But it would be definitely interesting to see what the impact is of that. Yeah.
Okay. So we are out of time, but there are some interesting questions in the chat. So I would kind of keep asking them. So Nilavara is asking, great talk. What advice do you have for future longitudinal studies in searches learning? What areas should we try to understand next?
Yeah, so that's a great question. So we don't have any longitudinal studies really in searches learning, right? Apart from this one by Mark Braun, where, I mean, you really need to find a good way of having many people that want to use your tool for a long time. So as an example, something I'm setting up with 2 of my students is I'm running a web technology first year bachelor course for 500 students. Great. I can't force them to use SearchX, right? They will go to the head of the studies and I'll get fired. So the question is, well, we know they all use Visual Studio Code for programming. Can we build the search system into Visual Studio Code, right? For instance, when we know they're starting with some JavaScript, can we pop up results from Stack Overflow to help them? So you need to find a way that what you do is beneficial to the students, right? I mean, I guess students are the easiest to access as academics, but you know, if you want to run a longitudinal study, you really need to think about what would help the student. And then the second question is, well, how can I turn this into my research? The other way around, I think, is not working, because students will abandon, right? And you can't force them to use your tool. So you need to do it in a way that they want to use your tool. So any longitudinal study in search-based learning would be great, because there's only like one or two so far.
Okay, thank you. And the last question from Jeremy Pickens. I work with searchers who prefer the power and flexibility of the Boolean retrieval model. These searchers are doing investigation or discovery. If search as learners are learning, then might that actually work better than relevance ranking?
So might Boolean retrieval be better than relevance ranking? So, I mean, the big issue we have with learners is basically they don't know what to search for, right? Because then they don't have the terminology. They don't know how things build on each other. There's a very cool paper at CIIR 2008 or 9 where people interviewed crafts people, like people that learn how to knit or to do woodwork. And, you know, they wanted to learn a new technique, but they didn't know, they struggled so hard to even describe the thing to their search engine. That was really the main point. You don't know what you don't know. It's impossible to, you know, to formulate some of these search needs. So I think Boolean retrieval, would be impossible for them. But if you have like very specific searches that are like deeply into the topic, then yeah, I think then Boolean retrieval might work.
Yeah, I understand. Jeremy is following up that these searchers worked for weeks and even months on one topic, so they learn what terms they need to use as they go.
Yeah.
So
yeah. Then I think in search-based learning, we're typically thinking about, you know, high school students or university students that need to learn something like now, not people that have been busy for weeks and months, because then they're experts, and indeed the tooling probably doesn't help them.
Okay, great, thank you. Thanks a lot for the interesting talk, and thanks everyone for asking these interesting questions. And this is the end of the talk, and we'll have another CIIR talk in 2 weeks from now. Okay, thank you everyone, and have a good day.